here. So
is that inconclusive or conclusive?
inconclusive is defective.
It's defective, so one, I think the number of retests is
Yes.
inconclusive, right? Or conclusive.
So these are the inconclusive tests, so they have to redo the test.
Oh, so one is the inconclusive, right?
No, this is sample
No,
number
the
one.
lower one. The below one.
Yeah, so we have one defective,
Oh, okay.
one defective out of 200.
So it's inconclusive.
Yes, yes. So, in upper and lower control limits for, so we're going to use the exact same formula. Okay. What are the upper and lower control limits? Okay, so P, okay, we need to find P. What is P? P is the sum of inconclusive tests divided by the number of total tests. Okay? So the sum of inconclusive tests, defectives, is 1 plus 2 plus 3. So the sum is the sum of defective tests, okay, divided by, we have 13 samples, and each sample has 200.
2006.
Yes. Okay? So that's how we calculate P. And then we need to calculate Z. Okay? Fortunately, the question says 2 sigma. Whenever you see 2 sigma, it means Z equals 2. If you see 3 sigma, that means Z equals 3. Okay?
So 2 sigma, that means they give out the result for Z, right?
Yes. So we know P, and then we know Z. All we need to calculate is sigma sub P. And this is the formula here. And then we just calculated P here. Yeah.
For P, is it like the same as the last one where it was 200 per sample, so it would be like 200 times 13?
Yes. So this will be 200 times 13.
Okay.
The denominator.
Yeah.
The numerator.
That's 25.
Yes.
25 divided 2006.
Okay.
Very confusing.
So P1 minus P divided by 200, which is our sample size, square root of that is sigma sub P. Is everybody clear? So once we know P, Z, and sigma sub P, we can calculate the upper and lower control limits.
So this one is exactly with the upper, like the upper question, right? The question 5.
Yes, which one, even if I don't know which one is upper, which one is lower, I can look, this is plus, this is minus. So plus means upper, minus means lower control limit. Yeah.
So when we plug in the n, that's going to be 200?
Yes,
Okay.
because how many items are in one sample? Okay, so then let's do the next question. The postmaster of a small western town receives a certain number of complaints each day about mail delivery. Determine 3 sigma. 3 sigma. So as soon as you see 3 sigma, you know z equals 3. Determine 3 sigma control limits using the following data. Okay, so this is day 1, day 2, day 3, day 4, and in each day, you have like day 1, 4 complaints, day 2, 10 complaints, day 3, 14 complaints. Here, we don't use the P chart. Why? Because we do not have a sample here. Okay? So, day 1 is one product, day 2 is one product, day 3 is one product, day 4 is one product, day 5 is one product. These are all single products. But each product will have some defects. This product had 4 defects in one product. This one had 10 defects in one product. This one had 14 defects in one product. Okay, so we don't have a sample.
So we look at like narrow down in just one product, right?
Yes. So we have 14 products, and these are the defects in each product. So since there is no sample, we use the C chart. We use the C chart.
No sample size.
Yes. So this is the C ratio, number of total defects, divided by the number of total items. The number of total items is 14 because we have 14 days. Okay? Number of total defects, we need to add up all these defects, 4 plus 10 plus 14 plus 8 plus 9, all of these, and you should have 110 defects in 14 products. Okay, so when you add up these defects, daily defects, you should have a total of 110 defects out of 14 items.
So in here is not the percentage anymore, right?
No percentage anymore.
Because the P is the percentage.
This is not percentage.
Yeah, but like for the one have the, but for the P chart,
Yes.
the defective is calculated as the percentage, right? The mean.
It can be percentage or decimal. Either way is acceptable.
Okay.
So let's go to the formula. So once we calculate C, the formula is like this. We know C, and then we know Z. Z is given 3 sigma. So C plus 3 times square root of C. And then for the lower control limit, C minus 3 times square root of C. Okay. Can everybody do this on the exam? Okay, question? All right. So all the solutions are also posted on Blackboard, right? So let me go to the solution of this. Okay. So this is problem 7. Okay. So I add up all the defects, it's 110. And then I divide 100 by 14 because I have 14 items. It's roughly 7.86 C. C ratio is 7.86. So I plug that into the formula. Okay, so 7.86 plus minus 3 times square root of 7.86. Okay, so this is the upper control limit. This is the lower control limit. Okay, so the lower control limit is negative, but we cannot have negative complaints. The lowest, like the least complaints we can get is 0. So we set this equal to 0. Okay. And problem 8. Problem 8. So, given the following data for the number of defects per spool of cable, so we have, again, 14 spools. Each spool is a single product. In the first spool, you have so many defects. In the second spool, you have so many defects, etc. Okay? So, and then they give us 3 sigma limits. So Z equals 3. So we find C by adding up all these defects and then dividing the sum of defects by 14. So that's our C value. And then we know Z, 3. And then we can find the upper and lower control limits. Okay, so this is the last question, number 9. Now, in this question, are we going to use a P chart or a C chart?
B chart.
Which one?
B.
P chart. Why?
They have sample.
Yes, because we have a sample. Sample size equals 100.